Hi, everybody. My name's Jeff Day. I am a PM lead at Microsoft, and I work on the Windows camera. With me today is Renee Schulte, who will tell you a little bit about himself, but he's going to be giving you a bunch of demos today, which I really appreciate. So what we're talking about today is modern Windows camera apps for both Windows and Windows Phone. In Windows Phone 8.1 that was announced this week, we have a bunch of new camera and imaging capabilities that Renee is going to be talking about. But to begin, I'll jump right into a demo. So this is Windows Phone 8.1 Blue. And actually, to show off the camera, what I'll do first is go to our new notification center. And all I did there was swipe down from the top. And you'll notice that there are 4 buttons here. Right now they say available, not connected for Bluetooth, airplane mode, and rotation lock. I personally prefer the camera button to rotation lock, so I'm just going to click rotation lock, switch it to the camera, and now I have the camera readily available from the lock screen. Whoops. I will lock the phone. Forgot where the power switch is on this phone. So if I pull down on the lock screen, I can jump right into the camera. This is the new camera app. I'm taking in a picture of all of you. I can do a video. I can do the traditional single shot video, a little overexposed into the lights there. And then we have a new feature in Windows Phone Blue, or 8.1, called burst mode. And to do that, why don't I take a burst mode of Renee here. Okay, and now when I switch over and look at the pictures I just took, we have the photos are processing. I captured about 20 or 30 photos there, so it takes a moment. And here we go. And a couple of things that you might notice is I can scroll through them and I get kind of a video effect. There's UI in here, so you can choose which photos you want to save. I like this one, so I can click on it and save it. Or I can click multiple. And one other thing that's kind of interesting about this mode is we actually have this thing called pass buffers. And when you take a burst photo, you actually get a bunch of pictures from before the time that you actually push the button. So if you have a kid that's running and playing soccer or something, you can just press the burst button and you'll get 5 or 6 frames from before you push the button. And it's kind of a never miss the moment type of feature. Now, what's new in Windows Phone Blue is this whole idea of convergence with Windows. The existing Windows Phone camera that ships that's in the Windows Phone devices that you have today is Windows Phone only. And it still works. And all of your existing photo applications will still work on Windows Phone 8.1. But what we did is we went ahead and implemented this new namespace in Windows Phone called Windows.Media.Capture. And it's the same camera API that exists in Windows. So you can write a single universal application now that that uses the same camera API, and it will work identically. In addition, there are several, just because of timing, Windows 8.1 shipped late last year. Windows Phone is shipping this week. Because we had extra time on Windows Phone, we've added some additional features that enable computational photography. Computational photography refers to the use of the computer to create better pictures. And a classic example of computational photography is HDR. In fact, Renee today will show an HDR application. HDR is high dynamic range, where you take an overexposed picture, an underexposed picture, blend them together, and you get a picture that actually has the best tones from both pictures. Enabling this feature is something called variable photo sequence, which is essentially if you've got a DSLR or other advanced point-and-shoot camera that supports exposure bracketing, variable photo sequence allows bracketing of your exposure as well as other parameters. Now, convergence was something, is something that's big across all of Microsoft right now. Our goal is to allow you to write common applications for both Windows and Windows Phone. You can continue to write a phone-only application using the existing phone API, but if you want to write an application that runs on both devices or tablets as well, you should go ahead and use Windows.Media.Capture. One thing to mention about Windows.Media.Capture is some of the advanced features that we're showing, especially the variable photo sequence, only works on the newer devices with new drivers. So Windows.Media.Capture does run on your old device, but the advanced features like variable photo sequence only work on the newer devices that are about to ship. A couple of final things before I hand it off to Renee. So I just want to tell you about some of the additional capabilities that we've added in Windows for the camera. We have full programmatic control of zoom. You can zoom during a video recording, zoom over still. That's not something that's available on the existing version of Windows Phone. We also have the ability for you to capture a still while recording a video. And finally, we also now support high frame rate recording. So you'll be able to do a high speed, say 120 frame per second video, and then slow it down to 30 frames per second for a nice slow motion effect. So with that very quick introduction, I'm going to hand it off to Renee, who has done some really great work to show you what's new with the camera in Windows.
Hey, welcome from me as well. Thanks, Jeff. So my name is René Schulte. I'm a Windows Phone development MVP and a Nokia developer champion. And I also work for a company called Identity Mine. And we're an interactive design agency. And we develop for all platforms, but have a strong focus on the Windows platforms like Windows Store apps, Windows Phone, also Xbox, WPF, and so on. And I also have a couple of my own apps, mainly focus about image processing and photo editing, and a few open source projects like Writable Bitmap X or an augmented reality toolkit. So I have a kind of a background in computer graphics and image processing. So I guess that's why I was asked to show you a few things about the new API, right? Okay, a few words about the agenda. We had the intro, and then I have split it into 3 sections, basically. And each section, I will have a short intro slide, or 2. Then we will have some demo code. And for the demos, I will show you the apps, and then we walk through the code, because I don't want to do any live coding, because watching me type is just boring, right? So, and after that, we will have a quick recap slide. So first one, we will start with essential capturing. This is basically showing you the bare minimum you need to know how you can get a photo from the device into your application, right? So it's basically about picking and using the built-in camera application. The second is called basic capturing, and this is showing you how you can implement your custom capturing solution. So how can you get a viewfinder experience in your app and take photos, record videos, and change camera parameters. The third part is about advanced capturing and mainly about what Jeff mentioned, the variable photo sequence. So let's get started, right? And we have some time for Q&A, hopefully at the end. So, essential capturing is actually about picking, right? So, and if you have done a Windows development, you might know the camera capture UI and have used it. But that is not available on Windows Phone 8.1. The good thing is, if you're doing a Windows Phone 8.1 Silverlight 8.1 development, you can still use the task. You can still use the camera capture task and the photo chooser task, but not for WinRT-based phone apps. But the file open picker actually covers most of the scenarios. So the file open picker allows you to pick any media files, to pick a photo, a video, or actually any document. So, and it really covers most of the scenarios. And I will quickly show you how it looks on the phone. So for this demo, I just show you the application. We won't go into the code for this one. But all the code, all the source code will be made available after the session. So you can just take it from there. So here's the demo. And this is a Silverlight 8.1 app. and we have the photo chooser task in here. So you can, probably most of you know it already. So you can pick a photo here and get it returned to your application. And the same experience can be enabled with the new file open picker. So we will launch the file open picker here, and it's basically the same user experience. And notice you can pick a photo, or you can take one right away with the built-in camera application. Cheese. And then, yeah, it gets passed back to the application. And you can also do it for videos. So this one allows to pick multiple files, photo and video, and they get passed back to the application. Pretty easy to use. You just need to define a file type filter for the file open picker. So you say, I want the user to pick JPEG or PNG files, and then the user will see the experience where he can pick photos. And if you want to allow videos, you select WMV or MP4 as allowed file type. One thing to keep in mind, it can be combined. So as you have seen, you can pick photos and videos or any of those. Important thing is that the workflow is different than for Windows 8.1. So for Windows 8.1, if you use the file open picker, you have an async method, which you can await. And when it's done, you get the files passed back. But this is different on Windows Phone because there's a different application lifecycle. So once you launch the file open picker on Windows Phone, your app gets deactivated, and the user sees the file open picker UI. And once he picked the file there, then your app gets activated again, and you get an activated event triggered in your app, which you can then check the type of the event args and get all the files. There was a session today by Arun and John. They covered all the details, how all the lifecycle management works. So check it out. It was recorded, of course, so you can watch it online later if you missed it. Yeah, good thing, what I also want to mention is with Windows Phone 8.1, we finally have access to the full media files. So you can load and write video files. And I know a lot of developers have been waiting for this one. And so give some claps for the engineering folks here. Yeah, this is good. And you can use the file open picker if you want to use the standard UI for picking files. And for saving, it's the file save picker. Or if you don't want to use an UI or want to implement your custom UI for picking, you choose the known folders API. And the known folders has some properties like camera roll, pictures library, and so on. So there you can enumerate over all files and present it in your custom UI or just load them in the background. And when I say load them in the background, this, of course, raises some privacy concerns, right? So you need to define the capability in your AppX manifest. Otherwise, it won't work. Because as a user, you don't want that an app loads stuff in the background. Also cool is, if your device has an SD card, you can change in the Windows Phone setting where the media files should be stored. So should they be stored on the internal memory or on the SD card? And as a developer, you don't have to care about it, because known folders will always point to the right place where the stuff is stored. So you don't need to read out the settings or anything. Just use known folders, and you can get the files from there. And as I said, all the source code will be available after the session for this demo as well. But we won't go into the code for this one because we have cooler stuff to show. OK, next section, basic capturing. If you have done a Windows Phone 8.0 development, you might remember the API we had there, which was the audio-video capture device and the photo capture device. And this Windows Phone Media Capture API is replaced with the Windows.Media.Capture API now. But it's deprecated, right? So it will be deprecated, but it still works. So, and I just want to show you that it still works. I mean, I can tell you a lot, right? So let's see a demo for this. So I have one of my applications loaded on this device. And I will open it through the lenses feature. So if you're not familiar with the lenses is basically an extension for your applications, where you can plug your own application into the built-in camera app. right? And if you tap it, like my Pictures Lab application here, it needs to launch right into the custom take photo experience. And this is one of my apps, and this is the 8.0 version of the app. So this is the running on a Windows Phone 8 device, but it's the 8.0 version of the apps. And, this is using the Windows.Media.Capture API, so the old one. And as you can see, it still works, so all is good. So why should you actually bother to use the new one, right? You might ask. Well, it's cooler. you have way more features, and it's easier to use. And another very important thing is you have a common API. So we have the same API can be used for Windows and Windows Phone, and there for WinRT-based application, and also for Silverlight 8.1-based application. Yeah, I think we have talking enough. Let's see some code, huh? Who wants to see some code? No one? Good, good. Okay, let's close this. Yes, so this is the basic capturing solution for our basic capturing demo. And it consists of a couple of projects in here. So I have this new universal project in here. And there we have a project for Windows 8.1 and one for Windows Phone 8.1, right? And as you can see, they're basically pretty empty. So you just have the AppX manifest in here. But both of those reference that universal.shared project, which is just below here, okay? And there we have all the helper classes and even the XAML. So for this demo, I even shared the UI for Windows and Windows Phone. So let's launch the Windows version of it. And it's pretty simple demo, so we have 2 pages here, and you will shortly see why. Hey there. So we have the real-time camera stream, and you can press capture photo, and this will, capture a photo. So let's see how it looks on the phone. Okay, basic capturing. So same user experience, same UI, everything the same. Real-time camera preview, capture photo button, and it allows you to capture photo. Easy scenario, not hard to implement. And let's see how it actually is implemented. Okay, for this one, I have a little helper class in here. It's called camera capture. And I did this because I want to show you that you can really use the same API for Windows and Windows Phone and even for Silverlight 8.1. So inside my little helper class here, I actually have the media capture instance encapsulated. So this one here, this field, media capture, this is actually coming from the new Windows.Media.Capture. So this is giving you the access for capturing photos, initializing the real-time camera preview, and so on. And if we go, so one thing, this is the context switcher, and this allows you to switch between different contexts. So we can view this file for our Universal Windows project and for our Universal Windows Phone project and even for Silverlight 8.1. So I have also a project in here for Silverlight 8.1. This is the complete same stuff. As you can see, it's really just the same file linked in here. So just to prove it, it's really a common API. Okay, so how does it work, you might ask? Let's look into the photo capture page. So this is the one page I showed you where you have the capture element, which is giving you the viewfinder experience, this little button down here, and the list view with the captured photos. And the capture element is important because this is giving you access to the real-time camera preview. And this allows you to show the real-time camera inside your custom user interface. And if we look at the code behind for this one, in the unnavigated 2, this is where we initialize all this. So we have this camera capture, and we call initialize on this helper method. And if we go to this, we will actually see how it works with the media capture. So we create a new instance of the media capture, and we just call initialize async on it. Okay, and then we can also define the primary use for this one. So this is an optional parameter. You don't need to define it. But if you want to, this allows the underlying core to optimize for certain scenarios. So if you know you want to capture videos, you probably want to pass capture use.video. Here we are doing it for photo, so we're passing photo. Then we are creating some image encoding and video encoding properties, more about that later, and then returning that instance of the media capture. Okay, so this is our instance of the Windows.Media.Capture class. And this instance is passed back to our capture element. So this preview element here is actually the capture element you have seen in the XAML. And this is a source property, and that source property is of the type media capture. So this is how you connect your actual media capture with your XAML UI. And then we just need to start the preview. Starting preview, super easy. Start preview async, that's it. So we have like 3 or 4 lines of code, and you can have a real-time camera preview in your application. That's really pretty easy. And how can you take photos? Yeah, well, that's not much different, or not much harder. So we use the known folders API I talked about a few slides ago, and the pictures library in here. And so we create a new file in the pictures library, and then we call a method on the media capture called capture photo to storage file async. And this one gets passed the file, of course, and also an image encoding properties. And with that, you can define what kind of file format should be used to encode the actually captured image. So you can say JPEG, PNG, BMP, and all what's supported. And you can say which size, so width and height, and also other parameters. Yeah, that's it. That's how you can capture the current view into a file. Pretty easy. Okay. We have another demo. As you might have noticed, there is also a video page in here. So let's see this. So this is, allowing you to capture video. So start video recording. And I have some sliders in here, which I can use in real time, so I can zoom in. And I can also change the hue, like the color value, so you all look like aliens. Or, yeah, like this. Yeah. And we can stop the video recording, and it will just play it back in a media element here. And as you can see, my real-time parameter changes were also recorded. Right? Okay, enough of that. Yeah, sorry. I had to do it. So how does this work? Capturing video is not much different, actually. So we have this video capture page. This is the page I just showed you. It has the camera capture element, like the photo capture page, and we have a stack panel with a couple of sliders in here, which allow you to real-time manipulate the parameters. And, sorry, we can see the code in here. So the unnavigated to, it's basically the same initialization stuff going on here. Not much different. And here's an interesting thing. So this media capture has a video device controller property. And this gives you access to the certain camera parameters, so like brightness, contrast, exposure, focus, and so on. You just saw it in the UI there. And I have a little helper method, which does nothing else than assigning that value, this media device control value, to a certain slider. And this video or media device control has a capabilities property. And this gives you access to the maximum and minimum supported value and also the stepping. So that's what we assign basically to the slider here and set the initial value of the slider to the current value the video device controller provides you. Yeah, and of course, we have a value changed event handler for the slider. And yeah, what else should we do there than setting the value with the one that came from the slider? That's pretty much it. So this is really easy to have those real-time camera parameter changes. Okay, and video recording is not much more complicated. So if we look into this one, this method, start video recording. This time we create a new file, but we use the videos library, because of course photos should go to the photos pictures library or camera roll, and videos should go to the videos library. And then we call a method called stored record to storage file async. And this allows you to record that video to a file. And we pass the video encoding properties, so you can define, like, if you want to use WMV, MP4, and what quality, and so on. The interesting thing is you also have a couple of overloads for this one, or similar method for recording. So you can say store record to storage file async, that's what I'm using here. And you can also say store record to stream. So you can record to any stream you want. And even a stored record to a custom sync. And a custom sync is one thing you can implement. So you can implement a certain interface. And then you have a custom sync where you can route all the camera stream into it. And you can do custom processing. So you can do anything you want there. So lots of possibilities. Yeah, and stop recording is even easier. Just stop record async, right? Yep. Okay. Quick recap about it. The new media capture class replaces the Silverlight 8.0 capture device classes we had. So we just have one now, just use media capture. And we have a common API. And there are only a small difference for Silverlight 8.1 based applications. So as you know, you have a different XAML stack for Windows.T and Silverlight. So there's a different way to connect both. And for Silverlight 8.1, you don't have this capture element, what I showed you, this XAML element, which gives you the preview stream. For Silverlight 8.1, you would use a shape like rectangle, or you can even use an ellipsis. And this has a fill property, and you can use a video brush, which basically routes the camera stream into this filling for the rectangle. And there are a few things to keep in mind. And as I said, the demo also, the Silverlight 8.1 demo will be available after the session. So I have the code in there, so you can just steal it, copy it over, and it's pretty easy. Another cool thing is the audio and video device controller, and where you can change the parameters like focus, zoom, and so on, what I just showed you, and even the region of interest. And the region of interest is a nice thing. There you can basically define, okay, this certain area in the photo should be used to capture the autofocus or the white balance and all these automatic measurement the camera does. Okay, and I just want to show you another demo on the device. Yeah, one of my other apps. I don't want to show my apps here because I actually was asked to show you a few things, what you can do with that. But so I was, I have to show you my app. So this is an app called FaceLens. And Jeff, if you would be so nice to come here. So this app does real-time face detection. And we can add Jeff a nice overlay here. Yeah, it's having some issues with the...
Should I move over here?
Yeah, here it is. So then you can fine-tune it and do some things with it. And as you can see, you have a wide range of things you can do with that media capture stuff. And you can even do funny stuff like FaceLens. Good. Next section, advanced capturing. The Windows Media Capture also brings some phone-exclusive APIs. So we have this common API I showed you, which is common about Windows and Windows Phone, Windows.T, and Silverlight. And we have some cool new phone-exclusive APIs. And one of them is the Screen Capture API. And the Screen Capture API is a very nice thing where you can record the current screen of your app, the current page, into a media capture. And it's very easy to use. You just get the current video source and audio source from the page and route it to the media capture. So you could just call initialize, like we have seen, but pass on some settings where you set those properties. The screen capturing is, of course, pretty important if you want to do like bug reporting or for games, I guess, like replay functionality or sharing some how good you are with the game and with your friends and so on. One important thing about the screen capture, the team also made sure that there are no privacy issues. Because, of course, as a user, you don't want that an app just records your current actions, right? So if the app wants to start that, the user gets a message dialog presented where he needs to allow this, actually. And then even some advanced things in there, like if there is a toast notification coming in with some private information, those frames will not be recorded. So they just leave them out, right? And also, if you have like DRM and protected media playing, this will also not be recorded. And there's another cool phone-exclusive API. It's called Variable Photo Sequence Capture. As you know, I mean, with those devices we have these days, like I have the Lumia 1020 here. I mean, it has an amazing camera, right? And it's better than average pocket cameras. So it makes sense to have some cool new phone-exclusive APIs available for phone. And one of them is the variable photo sequence capture. And what this gives you, it gives you basically a burst shot, so you can take a quick series of photos, but with the difference that the variable photo sequence capture allows you to define the camera parameters for each of those photos. So you can say the first photo in my sequence should be taken with an exposure compensation of -2, which is an underexposure, pretty dark photo, right? And you can say then the second photo should use an exposure compensation of 0, and the third one, an overexposure with an exposure compensation of +1 or something like that. And if you're familiar with image processing and stuff like that, you might already get where we're going here. Like, this is how you can implement high dynamic range photography. If you take those photos from the sequence and merge them after they were taken, you can implement a higher dynamic range photography. And this variable photo sequence is so fast that you actually don't need a tripod anymore. So usually when you take a sequence of photos, you need to use a tripod, because otherwise you're shaking too much, and you will get this motion blur when you combine those. But more about this a bit later. Cool. Demo time. Let's switch back to the PC. OK, nice. And there's a demo, advanced capturing. So this demo, this sample app I implemented, it gives you the viewfinder, and I also support the hardware buttons in here. So I'm just pressing the camera button up there for focusing, and when I fully press it, it takes a photo. And as you can see, it took 2 photos. So I'm using this variable photo sequence in here. And the first photo that was taken is this one. So this is an underexposure. It uses an exposure compensation of -2, so it's pretty dark. And for the second, I said I want a photo with an exposure compensation of +1, like this, right? So here in this one, you see the brighter regions with a nice contrast. And for the first one, you see the darker regions. And if you combine those, you get this higher dynamic range, right? So you see darker and brighter regions equally well. A few words about what HDR actually is. So the human eye has a high dynamic range. So human eye can see darker and brighter regions in the same scene, but with limitations, of course. But cameras don't have this high dynamic range. They have a really low dynamic range. So there's a trick you can do, like this high dynamic range photography. And if you look at the photos there, so the first one I took in a sequence, you see the clouds nicely, right? So, but the rest is pretty dark. And the second one, you see nothing of the clouds, but you see the street and the cars. And if you combine both, you have this higher dynamic range photography, this higher dynamic range photo, where both is merged, and you get best of the both worlds. One issue is, if there are moving objects in there, or if you're shaking, you will end up with like different motions, different scenes in the photos. And if you overlay them, it will get some kind of blurred, right? So we will end up with motion blurring. And this variable photo sequence API is so fast that you actually don't see them. So let's see some code. Okay, there's another demo, advanced capturing, this one. And we have our main page with the capture element in here and the list view and so on. And in the unnavigated too, we just create a new instance. So I have another helper class in here where I call initialize. And here's the magic happening if you want. So we create a new instance of media capture and call initialize async, all the same stuff I just showed you. And here comes the important thing. So we have the video device controller, and it has a property called variable photo sequence controller. And I just use it because I don't want to write all that in a line, so I use a variable here, VPC controller. And the first thing I want to do is I want to check if it's actually supported on that device. Like Jeff mentioned, not all devices might support it because you need a pretty good camera driver for this one. So you better check it in your application before you offer this mode to the user. And then here comes the interesting part. So this method gets a sequence count passed. And this is basically just how many photos you want to take in that sequence, nothing else. And then I read out the frame capabilities and use the exposure compensation from the frame capabilities and use the min and maximum value for this one. And I have a little for loop in here, which does nothing else than interpolating between the minimum and maximum for the number of photos I want to take. That's basically what it's doing. And for this, I create a new instance of the frame controller class, set the exposure compensation control value to the interpolated value, and add this one to the desired frame controllers. And this is important because this will add the actually camera parameter you want to use to this variable photo sequence template, if you will. And then we define the image encoding properties, what the image encoding should be used for this certain photo in the photo sequence. And here I use a BMP format because I want to process those photos in the end. I want to merge them, so I don't want to use JPEG. Because with JPEG, I would end up with some compression artifacts and all that. So I just use BMP, which is, as you might know, an uncompressed format. Yeah, and then we have defined what we want to have, like desired frame controllers. And then we call prepare variable photo sequence capture async. And this gives us an instance of the actually variable photo sequence capture. And this will be used to actually trigger the sequence. And it also has some events. And one of them is photo captured. And if we look into that event, this gives us a variable photo captured event args. And this event arg has a frame property. And this frame property is nothing else than a stream to the photo in the encoded format you have chosen. And it also gives you the captured frame control values. So these are the values that were actually used for the capturing. So you can read out the actually used exposure compensation. And what I'm doing here is just reading out that value, passing it to a string so I can show it in the UI. That's basically what we're doing here. And I also create a writable bitmap from that captured frame, so from that stream. So because I want to show it in the UI, and the computation uses writable bitmap for the HDR stuff. Yeah, and starting the sequence is pretty easy. You just call photo sequence capture start async. That's it, and then it fires off. And in between, that event will be triggered. So when this is done, when all photos were taken, I have the algorithm in here for computing the HDR. And this is using a background task, because as you have seen, it took a few seconds. So I don't want to block the UI here. We just run it in a background task. And I'm using an algorithm called exposure fusion, and I don't want to go into the details for this one. But there's a paper I have in my resource slide, which you can read. So this is an algorithm invented by a Belgian researcher. And I'm using an implementation in C# from my friend Benny Olsen, who implemented it in C#, but this is just for demonstration purposes, because it's not optimized, and there are some optimization possible you probably should do. Yeah. Async what? Oh yeah, so yeah, sorry, yeah. Yeah, you should not do this. That's you should do this. Very good. Thanks. Thanks. Yeah, I just missed it, right? I wrote this code and then I added the async and I don't know. Yep. I mean, it happens. We're all just developers, right? Yeah, and just a few words about how you can actually attach to the camera buttons. So as you have seen, I press the camera buttons on this device for triggering all that. And there's a static class called hardware buttons, and it has some events like camera half pressed, and also camera released, which I'm not using here. And of course, for camera half pressed, I'm triggering just the focus. And this is pretty easy. You just call media capture, video device controller, focus async. And in our case, this will trigger an autofocus. Yeah, that's how you can attach to the camera buttons. Cool. Let's switch back to the slides. Yeah, quick recap. Yeah, I just wanted to show that photo I took, because I think that speaks for itself. So I've taken this in my town where I'm from. I'm from Dresden in Germany. And I took this with this prototype device. So this is just a prototype device, a pretty average device, right? And only with 2 photos, with the same sample app I just showed you. And as you can see in that scene, you see this guy on the bike here, all those people walking through the scene. And they're not blurred, right? So they are moving when I was taking the sequence. So when I was taking the 2 photos or 3 photos, they were moving through the scene. And it was so fast, the variable photo sequence capture. When I overlaid them, you don't see a motion blurring. And that's pretty amazing, I think. Huh? I haven't measured it. But it seems pretty fast, right? I mean, you don't see motion blurring. And trust me, I can show you the original images for this one. Excuse me? Can you repeat the question? You can't see it? He was pedaling, yeah.
Yeah. The actual frame rates are device dependent, and they can even be dependent on the driver. Some of the drivers, for example, this particular device is a Qualcomm device, and it has wavelet noise reduction in it, and that slows it down. So it really does vary by hardware, by driver, and even by resolution. But frame rates of 30 frames per second are not uncommon. So that's about 33 milliseconds per shot.
Yeah. And just think about what you can do with those devices that have even optical image stabilization, right? I mean, this device doesn't have optical image stabilization, but others have. I have here. So you can use those. And I mean, this is tripod-free HDR, as I call it. So you can do HDR computation, but that's just one scenario. So you can, for the variable photo sequence, you can define different camera parameters. For example, you can also change the focus. So if you're familiar with the Nokia Refocus app, for example, where they take a sequence of photos, but with different focus values for each photos. And then in a post-processing step, you can select on a certain region in the photo. That's basically what they do, and you can implement it on your own. And the nice thing is it's really easy to use. It's not hard, actually. You don't need to be a big company or you don't need to have a PhD or something, right? So you can, every developer can implement it. And I think that's a very nice thing.
Yeah, another thing I'll add about the exposure time question is these photos, even if these were captured at 30 frames per second, the actual exposure may have been something like 1/60th or 125th a second, so a lot faster. But even at those speeds, if you have quickly moving objects, cars or running people or walking people, you might still see some motion blur. But there are different HDR algorithms that do a pretty good job of alignment and ghost removal, so that even in this sort of merge with moving subjects, you actually don't see the movement. It's pretty nice.
Another question around the support for the capture sequences, because they're not supported on all devices. And another issue that they reckon, because it did one of those refocusing apps, back with Windows Phone 8, not all
Can you do what?
Can be filtered by device. Currently, I can say, okay, this app won't run on a
Ah.
device that doesn't have a front-facing camera.
Yeah. So I'll repeat the question. The question was, well, first of all, the context of the question was that not all these new features, variable photo sequence, are supported on all devices. And then the follow-up to that particular piece of information was, can I make it so that my app is only downloadable on devices that have support? And the answer, I actually don't, I can get you an exact answer. The Windows Phone, but the Windows Store, I was going to say the Windows Phone Store, but we're now the Converge Store, so it's the Windows Store, does support filtering by device type, and it doesn't currently support filtering. When I say device type, I mean device. You can actually say, hey, this runs on a particular list of Lumia devices, for example. It doesn't currently allow you to say filter by devices that support the camera features. So in that case, you actually do need to write, I think Renee had an example in his code of doing the is supported functionality.
Exactly. That's the piece I just wanted to show you.
Yeah.
There it is. So you can check, is this actually supported?
The
And
actual problem isn't really is it supported because I can do the check in my code, but it's how to inform people before downloading the app that it won't actually work.
Yeah. I think the follow-up was, the challenge here is that how do you inform somebody who wants to download the app that it may not work on their device? And well, the capabilities have not been extended to clarify that this particular feature. We did discuss it, and it was a typical engineering trade-off decision because there are a lot of little details like that, and we have not implemented that particular check yet.
okay, can we wait with the session,
Yeah.
with the questions
Let's
for
hold
one
it.
slide?
We're going to
then
answer all
use
the questions you like, and I think Renee just wants to follow up. Yeah.
Yeah, and then use the mic for the questions,
Finish
because this is a battle for recording.
Yeah, this is being recorded, so please do go to the mics.
Yeah, but just one slide. You can fire off your questions pretty soon.
These are good questions.
Yeah, very good. Just the resources. So the slides and demos will be up at Channel 9, and the recording, of course. And you can also get the demo projects, all the source code for the stuff I showed you after the session. So I have a blog post. I just need to press publish on it, and then it will go live. So everything is linked in there. And Jeff's team also has an awesome sample. It's called the camera sample. And this is a full-blown camera application, and you can see everything in there. So check this out. And as I showed you, we have this common API. So you can also look into Windows 8.1 samples and just use those for, at least for the most things. Then a link to the HDR algorithm I use here, exposure fusion, to the paper, so you can read the details. And it's also, if you're capturing photos, you probably want to do more than just storing it. So and there I put a link for the Nokia Imagine SDK, which is a pretty nice SDK for free for all Windows phone devices, also for Windows. And it has really easy to use APIs for applying filters, cropping, and so on. So lots of possibilities there. And they even have a session right after this one, but not in this room, but you will find it in some other room. So they have a session about it. Yeah, and a link to my writable bitmap X library. I used it actually in the last demo where I had the writable bitmap to easily save it to a JPEG stream. So I have some helper methods in that library which can help for certain scenarios when you deal with writable bitmaps. And yeah, check it out if you have such scenarios. Okay, so
Yeah.
thanks so far. I think we will open up for Q&A now.
Well, and before we open for Q&A, I just have a couple of comments. First of all, this is I don't know how many of you will care. Some of you may. Windows.Media.Capture Capture is the existing camera capture API on Windows Phone 8, and that does still work on Windows Phone 8.1. However, when you recompile your app, you're now going to get a compiler warning that says that that API has been deprecated. Deprecated doesn't mean removed, and it doesn't mean that we're going to remove it right away. It just basically is our way of nudging you toward the converged API. So no functional changes, just a matter of, hey, let's think about moving to this new API because it is more feature-rich and it has convergence with Windows. I also just want to thank Renee. If I want you to walk out of here with any idea in your head, it's that anybody can write a camera app. And whether it's an HDR app or a simple take a photo of your whiteboard app or write a photo app that scans a barcode, the number of lines of code that you need to write to capture the image is very low. And the complexity of creating a UI around a camera application is very, very low complexity. So I think it's something that you really should have confidence that you're able to do. Of course, the more advanced stuff like HDR, doing some of that stuff yourself, the image processing can be challenging, but there are a lot of open source projects out there as well as other controls and whatnot that you can purchase. In closing, I also just want to say thank you to Renee, who's an MVP for us. And I just wrote him an email one day and said, hey, we want to show this stuff off at Build. And literally like 2 days later, he had working apps, even though I don't think he had seen the code before. So I guess that's a testament to the approachability of this API, but also a testament to his skill. So thank you for Renee. Okay, now we'll take questions.
If we want to start using this immediately, what are the hardware devices, both on Windows, full Windows, and on Windows Phone, that actually can support the advanced features you had? And corollary to it, is there any complications of writing this kind of an app with the HTML5 side on a Windows Phone as opposed to using the XAML that you used?
Yeah, so I'll answer the second part first, doing an HTML and JavaScript app or Windows Web Application app. I'm sure it's been announced sometime this week, but WWA apps have come to Windows Phone in Blue, and this API is fully supported in both the XAML app and the HTML app. And we have samples available for JSON.
I think I already saw actually a JavaScript sample for using the variable photo sequence capture.
Yeah, we have,
It's
and in
at
fact,
the code gallery, MSDN.
yeah, and if it's not, you can email me and I'll email it to you.
And then the hard part, the
Yeah.
hardware. What hardware can we use
Okay.
to test this right now? Both Windows and Windows Phone.
Yeah, I'll give you the quick but accurate explanation. The hardware is technically able to support this stuff on any of our devices.
Drivers.
It's really a question of the drivers, and right now the drivers are only going to be available for the newer devices that have Qualcomm 8x26 or 8974 chipsets. Currently, the only devices in the marketplace that have 8974 chipsets are the 1520 and the Nokia Icon. The other phones that Nokia announced this week also support it. The trick here is the 1520, which I have here in my hand, is currently running the Windows 8 driver instead of the Windows Phone 8.1 driver, and that update is coming sometime soon. You'd have to ask Nokia exactly when that's coming. In the meantime, if you want to develop, the only place you can actually run these APIs right now live is in the emulator on your PC.
Would the Icon have the drivers, the new drivers?
The Icon does not yet have the new driver.
And then on the Windows devices?
The Windows devices, so any Windows 8.1 tablet, you can use the photo sequence and the zoom capability, but the variable photo sequence feature that Renee was showing for HDR capture is currently available on the phone only, and that's not going to work on a device until you get the driver. Yeah. Question over here, then we'll come back.
Is there a sort of limitation for the resolution? Oh, okay. Is there a sort of limitation in the resolution in the sequence when you get a sequence? Because I'm thinking about in the 1020 you have a big resolution image.
Yeah.
So in that case, I can get the full resolution of the 1020 also in sequence.
Yeah, the 1020 is a little bit special, and I'll come to that in a second. To answer your more general question about
Yeah, but also the 1520 have
yeah,
a big
yeah. The intent with the photo sequence, which is the burst mode, and the variable photo sequence, is that you get full resolution still images. The caveat is that the 1520 and the 1020 have these super high-res cameras. The 1520 has a 20 megapixel, the 1020 has 41 megapixels. Nokia does not provide public access to that resolution for the simple reason that the thermal characteristics of the sensor are such that if you overuse it, you can melt it and do damage to it. So they actually hide those resolutions from apps. And typically, I think the publicly advertised resolutions on those are more like 8 megapixels or 12 megapixels. If you want access, it is technically possible to get access to those resolutions, but I think you'd need to go to Nokia to find out exactly how to do that.
It's in the API documentation by Nokia on Nokia developer, so you get this is set up.
Okay, yeah. It's a custom driver property that gets you access to it.
But for the variable photo sequence, yeah, I just wanted to point out, if you're doing variable photo sequence, the speed, like Jeff mentioned, also depends on the sizes you want to take, right?
This particular prototype, and I don't know if you changed it, supports 8 megapixel.
Yep.
I think those photos that Renee was showing were probably captured at 8 megapixels.
It was a lower resolution because it was faster to capture and
Yeah.
faster to process actually with the HDR algorithm, because as I said, it's not optimized for speed.
Okay.
Question. One of the things that the SDKs have always ignored is the EXI data, which is attached to the photo, which has information about longitude and latitude stored in the format of the photograph. Will the SDK now or in the near future be able to support either updating it, such as with compass headings and other, and able to read the information out of the file?
Good question.
I was going to see if you had any answer.
That's one for you.
Yeah. So right now, it's somewhat device dependent. Each driver manufacturer exposes their data in different ways. What we've done in Windows Phone 8.1 is you do now have an ability to get uncompressed NV12 frames up from the camera driver. And you get these opaque blobs of EXIF data that are provided by the driver. It's possible for you to tweak that, to read the data out of those blobs and to write your own data into it, but you're having to crack open this undocumented opaque blob. It's possible that somebody might write a blog post about how to go about doing that, but it's not a formally supported thing in the SDK.
Why isn't this actually, why is not the ability not to get to this information available? Because it's a wonderful place to put additional information.
That's exactly the conversation we're having internally right now, and we are talking, my team is actively looking at that kind of capability for, let's just say, a future release. Let me acknowledge that you're right that getting access to read and write metadata is an important capability.
Because currently I have to store as an XML file, and hopefully the XML file, when it tracks, they haven't renamed the file, I'll have to go back in, and if I can get to the GUID inside of the thing, I can match them up, but other than that, I can't.
Yeah. Sync with me afterwards, and if anything, at this point, I'm interested in collecting feedback about this kind of thing, because the more customer feedback we get about saying, hey, this particular capability is important, the better ammo we have to justify to ourselves that it's a good investment.
Hey, we will take the other question as well, but I just wanted to point out that your feedback is important.
Oh, yeah.
So if you like the session, please provide the feedback.
Yeah.
And we are almost running out of time, but we will take the questions. But I think Jeff and I, we will stick around also.
Yeah. We'll take questions as long as you guys have them.
And I will also be, so my company has a booth over there, so you can come there and I will answer some questions as well.
One other bit of housekeeping, they get handed this before. There is a Windows Code Challenge with a grand prize drawing, and that drawing's been moved from 6 p.m. to 6:30 p.m., so it doesn't conflict with another session. So if you're planning to go to that, just know it's been moved to 6:30. Question over here?
Sure. You guys talked about image capturing and video capturing. Does anything change with like the filters for the camera with the new APIs or SDKs?
Well, when you say filter, can you be more specific?
Just the ability to write like a camera filter for Windows Phone.
You mean a real-time filter?
Real-time filter, yeah.
Yeah, you can use MFT.
Okay.
Yeah, there's a Windows.Media.Capture has this API or this method called add-effect async, and it allows you to, and you can also write a custom sync, Media Foundation sync. But as long as you're comfortable writing native Media Foundation code, you can do anything you want.
Okay.
Yeah.
Hi. So To what extent is the camera selection process converged between Windows and Windows Phone? Because obviously in a phone you've got front and back, and on a computer you've got any number of webcams plugged in or whatever.
Yeah. I would say essentially they're not converged. They're still different devices. The phone typically has a front camera and a back camera. PC, a tablet might have one or both, whereas a PC typically has a USB camera.
Right. So I mean, so are those APIs at all alike, or do I have to, if I'm writing a universal app, do I have to sort of check both to see what's available?
Right now, you're going to have to check both. And there's also some other nuances, like the phone has a hardware shutter button typically, and the tablet and the PC don't. And although that particular API is almost trivial, it's just a simple.
And the other question I had is, all your examples were C#. Is there anything different using other languages, or is it all the things are available through all this WinRT?
It's just because I like C#.
Okay, that's fine.
Yeah.
But you can use
Everything.
C++.
You can use C++, CX. You can use JavaScript and HTML5. Also, everything that we showed works in both Silverlight 8.1 as well as the new modern XAML language or app model.
Yep. And you can enumerate over the supported cameras using the devices. So this is using the WinRT APIs, and you can enumerate over all those and find out how many cameras that device have.
On both.
At some point, they might even put cameras on the side. I don't know. So you can enumerate over there.
If somebody's shipping a camera with phone with two cameras on the back, it's an Android, but they're shipping it.
Yeah.
Yeah, you can enumerate over them.
Yeah.
So
Our architecture supports that, so should HTC or another vendor want to ship a camera of that manner,
I guess
it'll work for you.
I guess he's referring because in Windows Phone 8.0, you just said front and back camera, right?
Yeah.
And in the new APIs, you can enumerate over all.
Okay.
One of the things that we've talked about is that, and really it's up to an individual camera manufacturer to decide how they would implement dual cameras like that. But they could do a picture-in-picture solution, or using a photo sequence, you could actually get a sequence of frames, alternating every, the odd frames would be from camera A, and the even frames. would be
Nobody's
from
supporting
camera
turning
B.
them both on simultaneously, like you could turn on two webcams simultaneously on a PC, right?
I'm sorry, could you?
Nobody's supporting actually turning on both cameras simultaneously full.
It's technically possible. To do it on the PC with webcam, you'd probably want to write special drivers that know how to manipulate or how to enable two cameras simultaneously. So.
Okay.
All right. Thank you very much for coming.